One, two, three. All right. Well, good morning, everybody, to session 9 of Wind Turbines and Towers with Borum Energy Solution. We have a very exciting agenda today. Uh, so here, what we're going to talk about, we're going to finish the installation. So we're going to talk about wind turbine blades and furling, how to install it. We're going to talk about the electric box that goes at the bottom of the tower. And finally, we're going to look at the dump load. So by the time we finish all this, your tower is ready to be raised, understanding that last week. So recall from the last session, we installed a gin pole, right? That's a gin pole, and that's a tower that's horizontal here, right? We also show how to raise and test the tower, right? We call it test the tower before you install the turbine, make sure everything is okay. So we went through that. And also last week, last session, we connected the wind turbine, both mechanically and electrically. So the turbine is attached to the tower, and it's ready to go. So that's is why now we're going to talk about how to attach the blades. All right. So there's obviously 3 blades. They're made of carbon fiber. And the part that, so here they are. They will paint them black. And here, this is the blade root, and that becomes important as we move forward on how to install it. So there's the blades here, and this is what it's called the hub, right? So the hub has 2 components. There's a back hub and a front hub, all right? And the back hub is connected to the shaft of the generator. So have the blades pick up the wind energy, they turn, and by turning, they turn the generator and generate electricity. That's kind of a easy way to explain that. So the hub itself, 2 components, is secure by 9 connecting bolts and nylon nuts. All right, you can see there's 3 on each side. All right, so it's not going to go anywhere. We deliver it when you buy a turbine, when we ship a turbine, it's already in place. It's, the hub is connected to the shaft and all these bolts are in, but they are loose. And they're loose so that we have clearance to insert the blade root in it. All right. So here we go. So this is the thing again, and you have 2 holes here. Right? So these 2 holes are for the blades. So the way to do that is you insert the blade, each blade, all the way in until the holes in the blade that's already been pre-done. So the blades are delivered with holes in it at the right spot. The holes are in line with the holes in the hub. That's pretty straightforward. All right. So at that point, you secure the blade with the specified bolts, washer, and nut. So for each blade, there's 2 bolts that goes in there. All right. And with the washers and the nut at the back. So now, once you've done one, you can repeat for the remaining 2 blades. Pretty straightforward. Once you've done that, then it's time to tighten the 9 bolts of the hub and the 6 blade hub bolts, right? 2 bolts per blade. The manual will tell you the pre-tension to apply to each of these bolts. Okay, so tighten them up. You probably need to do a couple turns, a couple circle on it, right? To make sure they all have the same tension. Now you can see that with 9 bolts here and 2 more for the blades, this is not going to get loose, right? It's pretty solid and has to be because of the RPM that will reach and also the energy that will be taken by the blades from the wind. All right, so that is the blade. Okay, at that point in time, what's left to do? Piece of cake. So it looks a bit better. Aesthetic, I guess. We have a comb. It's an aluminum cone. All right, so you have to you place the cone on the hub, and it comes with washers, lock washers, and bolt. And basically, there's three spots pre-tap on the hub front component, and you just apply those things, secure it with that, and we recommend at this point to apply red Loctite on the bolt, which is provided in the kit. Okay, so at that point in time, once you finish this, you have turbine, three blades connected and secure, and you got the cone. All right. Now, we're going to connect now the furling system to the turbine. The furling system consists of a boom and a vane. Okay? So here we go. What's the material? Well, there's a boom, aluminum. Right? You'll notice one hand has 5 holes for 5 bolts. On this hand, you have 3 holes for 3 bolts. Okay. This is the vane. That's not a very good picture, is it? Okay. And this is what we call the boom interconnect. So this is the mechanical component that connects the boom and the vane connected to the turbine. It's all metal, steel, galvanized. All right, so step one, you recognize the boom interconnect here. Now, the boom interconnect comes already on the turbine. You don't have to worry about that. So when the turbine is delivered, it's already in place at the right place. Okay, so it comes like this. So the brown that you see here, this is already on the turbine. All right, so the first thing to do is connect the boom to the boom hinge interconnect here. All right, so you got 5 bolts, 10 washers. We recommend putting a washer on both sides, 2 washers for both, and nylon nuts. Once you've done that, tighten all the bolts to the pretension stated in the assembly manual. Pretty straightforward. That's how it goes. Okay, so what we have here is just to finish this. We have the boom here, right? Part of the boom that you've seen. You got the boom junction interconnect here and the hinge. Okay. Now, once you've done that, it's time to go to the vane. Okay. So coming back here, remember I showed you here the boom interconnect here with the 5 bolts, right? So you go to the other end of the boom. You have the vane. You'll notice the shape of the vane. So you want to make sure that you have this side of the vane connected to the boom, right? For that, so that's the vane made of aluminum 6061 T6. So is the boom. The boom is made of aluminum. So here you have 3 bolts to secure the vane to the boom. Right? And once you've done that, then you tighten the bolts to a pretension that's in the manual. Pretty straightforward, right? Pretty straightforward. All right, so that's the boom, vane, and the blades. All right. So now we're going to go to the bottom of the tower. A couple things to do there. One is it's a metal tower, so obviously we need a grounding plate in case lightning hits it. Pretty straightforward. So grounding plate material, we have a ground plate, a ground wire, and a grounding clamp. Most of you probably have used this in the past, or maybe not, but it's pretty straightforward. So you dig a hole 3 feet deep, wide enough so that the grounding plate is placed horizontally in the hole. Poof. All right. So you have maximum contact surface. All right. You connect the ground plate with the ground wire here. So you have a ground wire, connect that to the ground wire. You connect the ground wire to the tilt tower base. And before you do anything else, this is where you test the connection between the ground plate and the tower. So with the multimeter, you do that, and you should have a closed circuit, right? Because it's connected. If you don't, then you go back. You don't want to do that before you close the hole or fill the hole. Once you've done that, you're ready to go. So that is the grounding plate. Okay, at the bottom of the tower, you provide it with the electrical box on the pedestal. So here's the material, and we'll talk about what happens there. So this is the box. It's an IP65 box, rated for tough weather, rain, snow, whatever. There is, there's a column base here. There's a rod. There's a drop-in anchor. There's the column base here, and then there's an anchor rod. Okay, so we're going to spend a few minutes to talk about how and where to install this. By the way, this box is required by the Canadian Electrical Code. I'm trying to stay in good relationship with the Canadian Electrical Code and ESA. Okay, so here we go. The first you have to do is find a place to install this electric box with a pedestal. And a lot of people make this mistake. So we put this diagram here. So here's your tilt base, right? So the tower is like this horizontal, right? And go up this way, right? So the last thing you want to do is put that pedestal here or here. It will be in the way when you raise the tower, right? Might as well know this before you go too far, right? So it could be on the left side or it could be on the right side. Doesn't matter as long as it's not too far and it's on the side of the thing. The other thing is this is the column plate here, anchor plate. So you want to this way open towards the tilt base and not this way. Okay, so it's pretty straightforward. All right, so you drill the 5/8 2-inch holes in the concrete. You insert the drop-in anchors, secure the anchor, you screw the threaded rods, and then you place the column base on the 4 threaded rods. Now, my experience with all this is I would not personally drill all 4 holes at once. I think that I would just put the base here, column base, on the ground and identify one hole, drill the hole, put the rod in it, and then put it back and identify the next hole. The odds that if you do that all the 4 at the same time, some of them will be out in distance. So that would be the way I do it. But the principle is the same. Drop in anchor with rods so that the base is held. Okay. So now the next step is what? Well, you secure it. You secure and install the column. You can see here, you have the base and you have the column with 2 bolts that goes in it. This is how they pre-hold. So you just put the bolts in and secure it. And then at the top of the column, there's brackets to install. So then you can connect and secure the box. So this is how it's done here. Right, we got the brackets, and it comes along with bolts, nuts, and washers. And what you get at the end is at the top of the rod here, column, and you get the 2 brackets that are designed to connect directly to the box. So we finished the job here. So we have already installed this. You can see that this is close to the tower here. So you have the box here, and you can secure the box on these two brackets. What you get is this finished product. It's about 3 feet off the ground. And as I said, it's an IP65 box. It could be buried into snow and all that. Nothing's going to happen. That meets the code. And this is what the big picture looks like. You got the tilt-based tower here with the tower tube. And you got the box beside it. Not too far. Okay, so at the end of the day, we need to talk about why do we have this electrical box and what does it do? Well, two things. Content, it's got thermal blocks. It's got a three-phase, two-pole switch, which is here on the diagram. And you can see it on the box here. It's got fuses on the AC side. So the generator, the wiring, the cable coming from the generator connects here, and we'll talk about that in a second. So it's a three-phase wild AC. Wild because the frequency is a function of the RPM. Because up and down, there's not much you can do with this, right? So wild AC comes in this way. All right, here's the switch. There's the fuses that are connected here. Here's the rectifier that goes from AC to DC. We have a fuse on the DC side. And then we'll go back to thermal blocks. All right. So it's already pre-wired, tested, and all that. So it's ready to go. Here's a view of what it looks like inside. All right. So all of you, well, some people ask, what's the purpose? So before we go too far here, this is where the cabling coming from the turbine comes in this way. And then there's terminal blocks here to connect the cables, really straightforward. And then the cable going to the battery room connects here. And the terminal blocks are here. All right, so it's pretty straightforward. Okay. At this point in time, before you make the final connection here, good to validate that the cabling all the way from the turbine is still doing just fine. So in the assembly manual, we identify the resistance phase to phase across each wire. So we've already checked that before a couple times, but you know, it's like cutting wood, right? Measure 3 times before you cut. So measure, validate, validate, and validate. Okay. So this is already pre-wired. It meets the code. Okay. And this is where you go to the, is you put your cable to go to the battery room. Okay. That's a bit the thing here. So you're going to ask, some people say, why, what does it do? What's the 3-phase, 2-pole switch, right? So this is mandated by the Canadian Electrical Code. And what it does, it's a brake switch. So when you turn it on, it closes all the circuits. Remember this one here? It closes short all the phases. Okay. And what it do is that basically it slows down and stops the wind turbine from turning. Technically, it's called an electromechanical brake. It's all electronics. Okay, so it's a safety thing. Now, full disclosure, it's required at the bottom of the tower. I have some clients that decide to override that, and they put it in their battery room. The idea being they don't want to have to go outside in the rain, the snow, or cold to go do that. They can do it in the comfort of their battery room. Well, up to them to deal with ESA afterwards, but technically it needs to be there. Okay. One more thing I want to say at this point in time, you see there's a rectifier in the box. So depending on the distance between the box or the bottom of the tower to the battery room, it might be advantageous to move the rectifier in the battery room, right? The idea is AC is less losses than DC, but the cable is more expensive. So we have some software that will tell us what is more advantageous and what kind of size cable you need if you go AC all the way to the battery room. So we can do that. Normally, right away, I can tell you, if you're within 100 feet, it's not worth looking at. You as well stick with DC, but after 100 to 150 feet, it's worth looking at. So we have software that can analyze and provide the optimized solution based on cable sizing and distance. But the longest distance we have so far installed is 430 feet from the battery room to the bottom of the tower. Okay. Last but not least, the dump load. Not exactly a marketing term, but it is what it is. It's a dump load. So a lot of people, a lot of companies trying to understand why there's a dump load for wind turbines. You don't need that for solar panels, right? So why is this? Well, the dump load basically is there to absorb the electricity from the turbines when the batteries are full. So the charge controller for wind, just like solar, will assess when the batteries are full. Right? If the batteries are full, you don't want to send more electricity there. First, it won't take it. Second, it's not good for the batteries. What do you do with that electricity coming from the generator? If we don't have a place, if it doesn't have a place to go, it stays in the generator, has nowhere to go, and it turns into heat. That heat can boil at a certain point, and it will burn the generator. Okay, and there's a number of calls we get. People say, I don't understand now, my turbine's been there for 3 years, and now it doesn't work. It looks like the generator, we open up, it's burned. That's because of that. Okay, electricity has to go somewhere. Solar panels, they don't care. If there's nowhere to go, they just sit there, right? They don't generate heat, they just sit there. But a turbine is totally different. Okay, so what are the components of the dump load? It's very simple. We have CSC approved electrical box. We have ceramic resistance. They're ceramic because they don't flame, very safe. And liquid tight connectors. It's pretty straightforward. So what you do is the dump load is provided by our firm BS. It's already pre-wired. So you can see here the connectors, the resistance in the box, already wired inside. So the only thing left to do on site installation is to connect the system through the liquid tight connector to the charge controller. So it's the charge controller that will decide when to send the electricity to the dump load or when to send it to the batteries. All right. Normally, there's also we support a conduit, right? A liquid tight conduit that goes from the charge controller to the box here. So it's nice and tight and all that. And the box is rated by CSA, so it's fully electrical. Now, what some people do, and I hate to say that, but they do, is they make holes in the box a little bit. If the box is inside, they make holes in it so the heat can escape and warm up a little bit, the room or whatever. But I wouldn't count on that too much. The ceramic resistance, 1 ohm, and each one is good for 1,000 watt. So for the NRI, you get 2. That's 2,000 watt. That's higher than the fully rated of the turbine. And for the Honora Plus, you get 3 of 250 kilowatt each. So they can take the full load of the turbine.